Hello and welcome to another video. In this video we're going to be working on trapping rainwater. And this is a pretty common interview question and it's kind of old. So it's definitely kind of easy, or it's definitely kind of hard if you haven't seen it before. So in this one, you're given n non-negative integers representing an elevation map where the width of each bar is 1. Compute how much water it can trap. And here, so basically you have heights. So these blocks are heights. And then we have to determine how many blocks of water there are here. So in this case, there's 1, 2, 3, 4, 5, 6 blocks. And we're actually just going to look at this picture to do everything. So the main hard thing to this problem, honestly, and once you get it, it's pretty easy. And we're going to do the O(n) solution here because I think it's more intuitive. There is a constant time space, not constant time, constant space solution, but I think it's way less intuitive, and it's also kind of only relevant to this problem. So like, it's kind of stupid to memorize a specific solution to this problem, but you can look at it if you want to. So anyway, so the main thing we have to figure out is, like, for each block, like, what determines the amount of water that's in the block. And you might think it's just going to be like the minimum of the left and right height here, like for in this case, like, yeah, the height here is 1, the height here is 2, so this block can only hold 1. But that's not necessarily the case. It's not always the block right next to it. Because imagine we add a block here, like this. So let's say we add a block here of height 3. So this is all block, and there's no water. Now, what would the water look like? Well, actually, the water for this whole section would fill up like this. And then the water for this whole section would fill up like this. So notice that even though we didn't change the height to the left of it, when we affected another height, it still gave it more water. And so the main thing to figure out here, and you can kind of do it after looking at these enough, is actually what determines the height of the water. So let's get rid of this and let's figure it out. So basically what determines the height of the water is the minimum of the max height on each side of the water. So like I said, if there's a block here of 3, there's a block here of 3 that's height, this water would actually get filled up all the way, right? So for this particular block, the minimum of the 2 left and right maximum heights is 3 here and 3 here, right? It's kind of like, for every number in this array, give me the biggest number to the right of it, and then for every number in this array, give me the biggest number to the left of it. So you can just do that with like a simple one pass in one direction, one pass in the other direction, right? I'm not going to go through how to do that. It's like really easy. So once you know that, once you know like what's the biggest number to the left and the right, it's pretty straightforward to actually figure out how much water goes in here. So for example, in this, the biggest height to the left is 1, the biggest height to the right is 3. That means this block can contribute at most 1 water. But this is how much it can contribute. So can contribute. But the actual value that it does contribute, so contribution equals height of the cell minus can contribute. So minus can contribute. I'll just write it like this, it's fine. Because, like, let's say this cell can contribute 1 block of water, like we determined, right? Because it's the minimum of the 2 maximums, right? The minimum of this and this. It can contribute 1, but what if this was just like, what if it was like this? Then this wouldn't contribute anything, right? So the most it can contribute if it's empty is the maximum of the left and right maximums, or the minimum. And like I said, to get the maximum is pretty straightforward. You would just go through the array backwards, right to left, to get the biggest number on the right, and then you'd go left to right to get the biggest number on the left. Pretty easy. And we're actually going to calculate the biggest number on the left and the number it can contribute in the same time. So we'll only make an array of the numbers to the right, and then the other one we'll just calculate in, like, as we go. It'll still be O(n) space though, but I think this is the one that's a lot more intuitive than the 2-pointer. So basically, I'll show how to do that in the code, but basically now for every cell we can say, like, okay, what's the maximum to the left and what's the maximum to the right? So the maximum height to the left is, there's nothing, so this is 0. The maximum height to the right is 3, right? So, and we can even show this with, like, this is a height of 1, this is a height of 2, this is a height of 1, this is a height of, or we can even draw it in here, right? So 1, 2, 1, 1, 3, 2, 1, 2, 1. And let's just say these two out of bounds things are 0 and 0. So the maximum to the left is 0, the maximum to the right is 3. So this can only contribute 0, right? Because it's the minimum of those. So this will contribute 0 water. So maybe we can have the water in different colors. So this will contribute 0. Now this one, Same thing, maximum to the left is 0, so this can't contribute anything. Now here, the maximum to the left is 1, and the maximum to the right is 3. So the most it can contribute is 1, and the height is 0, so we'll contribute that full 1. Now here, the maximum to the right is 3, and the maximum to the left is 1, so the most it can contribute is 1, but the height is 2, so the water is blocked out by the actual height of this thing, so this won't contribute anything. So here, the maximum is 2 and 3, so the most it can contribute is 2, minus the height, so it'll contribute 1. Here, same thing, 2 and 3, no height, so it'll contribute 2. Here, same as this one, left 2 and 3, and it can only contribute 1 because there's a height of 1. Here, the maximum to the left and right is both 2, but it's a height of 3, so it'll contribute nothing. Here, it's left is 3, right is 2, but it's already a height of 2, so it can contribute nothing. Here, left and right, or here, left is 3, right is 2, so the most it can contribute is 2, but it has a height of 1, so it can only do 1. Here, it's going to contribute 0 because left is 3, right is 1, so it can only contribute 1, but the height is 2. And here, right is 0, so it'll never contribute. So you just add these up, so you get 4, 5, 6. That's basically it. So for every cell, just keep track of like what's the maximum to left and right, and the most it can contribute is the minimum of those two values, plus or minus its height, because the height, like the water can't be in the brick, right? So that's kind of the idea. Now, like I said, there's a 2-pointer. It's pretty confusing, and it's super specific to this problem, so I'm not going to go over that one. So let's just do this solution. And yeah, like I said, once you realize like how to figure out how much water each index can contribute, then the problem is pretty easy. So let's go with that solution. So first, we're going to calculate the maximum to the right of every number, and then we're going to do the left in place, as I said. So we'll say like int array right max or something, and this will be length of so this will be the length of height. And then we'll get some values here. So say like int h equals height length and a result, and we'll do a left max as well. So int left max that we'll calculate on the fly. We'll just make it 0 for now, and this will be length of height h. Okay, so we're going to loop backwards. So we'll say for the last index, this will always be 0, right? Because there's nothing to the right. So we're going to go through every index except for the last one, because the last one will always be 0. So we'll say I equals h minus 2, and then I is greater than or equal to 0, I minus minus. So we just go backwards. And we can say here that right max of I equals, so it's going to be right max of I plus 1, or the actual value of I plus 1, the bigger one of those. So height I plus 1. And this will be just a math max. So that will give us the biggest value to the right of every number. And now we are going to loop forwards now and calculate all our results and the left max in place. So like I said as well, for the left, this first index can never have any water because there's nothing to the left, so the left height will always be 0 here. So we can loop through every number other than the first one. So we can just go the other way. We can say I equals 1. I is less than h. And we can just say, so first we have to calculate actually, do we have to calculate the left max? Yeah, we do have to calculate the left max first. So we can say left max equals, and this will be the same kind of thing, except now we don't have an array because we're doing it in place. So this will be left max. Yeah, and then this will be height I minus 1 now. So we get the maximum to the left. Now that we have the maximum to the left in place and the maximum to the right in the array, we can just do our equation here. So we can just say, I guess, so first we get the actual, like, what it can contribute, right? So we can say, like, int contribution equals math max of left max, or it's going to be the minimum of these two, of left max and right max. Then we basically add that to the result, but like I said, if this contribution is less than or equal to the height, it will not add anything. So we can just do something like this. We can just do a math max, I think. Yeah, so we can do a math max of 0, and then a contribution minus the height of the actual cell. That way, if this is, let's say the height of the cell is 3, but it can only contribute 2, then we'll just add 0 instead. So that'll take care of our negatives. Or alternatively, you could get this value and you could say if it's greater than 0, then add it. That's fine too. Yeah, so then we just return the result here, and that should be int in theory. Let's take a look. No, this would be int. And yeah, I think this is a lot more intuitive than the 2-pointer. And if you want, you can if this is still not intuitive, you can do 2 of these loops and get both these arrays. So let's see. Oh, this should be right max of I. Okay. So yeah, the only difference between this and the 2-pointer is this is linear space, but I think, like I said, this is a lot more intuitive. So time here will be O of n and space O of n. And yeah, honestly, like I said, the trickiest part, so I wouldn't say it's really a hard problem, but the trickiest part is figuring out how to know how much water you actually contribute, like what are the things that actually matter. And once you realize the only things that matter is the maximum height to the left and the maximum height to the right, then it's pretty easy to do. So yeah, I think that's going to be all for this one. Hopefully you liked it, and if you did, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.